Hello everyone, welcome to today's video on Newton forward interpolation. In this session, we will learn a great method of interpolation that helps us estimate values between the data points using the polynomial functions. Let's get started. Before we jump into the Newton forward interpolation, let's quickly refresh our memory about interpolation. Interpolation is a method used to estimate values between the known data points. It's like connecting the dots on a graph to create a smooth curve or line that passes through all the given points. Like this. If you want to know more about interpolation, then watch my previous video in this playlist. I will also provide the link in the description box. Now let's talk about the Newton forward interpolation. It's a specific method of interpolation that helps us find the values between data points using the polynomial functions. It involves constructing a polynomial equation that passes through a set of data points in the forward direction. It's called forward because it uses the data points from the beginning of the data to estimate the values ahead of them. This is known as the base value. We will learn more about this in the examples. For now, let's see the working of this method. We start with the equally spaced data points, or we may call them equidistance data points. These data points could represent measurements over time, distances, along a path, or any kind of sequential data. Next, we calculate the difference for these data points. These differences are like the building blocks for constructing the polynomial equation. For this, we must understand the forward difference table. If we have equidistant data points x and corresponding values given by a function y which is dependent on x, then its statistical table will look something like this. Now to construct this table further, we will use a forward difference operator called delta, which is denoted by a triangular sign. Using this delta, we will further construct our table. For delta y, we find out the difference of two consecutive y's. For example, delta y1 will be y2 minus y1. Similarly, delta y2 will be y3 minus y2 and delta y3 will be y4 minus y3. In a similar way, we will calculate delta square y. Here, delta square y1 will be delta y2 minus delta y1. Further, delta square y2 will be delta y3 minus delta y2. In the same manner, we will calculate delta cube y and more values of delta raised to the power n, depending upon the original data points available. Next, we use the Newton's interpolation formula to construct the polynomial equation. This formula takes into account the differences between the data points which we have calculated in the previous step. Here a is the base value or the first term. H is the equidistant value between two consecutive points. H is also known as the interval of difference. And U is written as x minus a divided by h. This formula is particularly useful for interpolating the values of fx near the beginning of the set of values given. If I write this formula in terms of x and y, we may rewrite it as y of x is equal to y naught plus u delta y naught plus u into u minus 1 by 2 factorial delta square y naught and so on up to the last term. Once you have the polynomial equation, You can use it to estimate values between the given data points. Simply plug in the desired input values into the equation and you will get the corresponding estimated value outputs. Now let's understand how is it derived. If you want to skip this derivation part, then you may watch the next video in this playlist to directly move to the example. For the derivation, we must imagine a function y which is dependent on x. Let's draw a graph for this. We can write this yx in a generalized way like this. Let this be equation 1. Now let's put the value of x in the equation number 1. We will get y0 as a0, y1 as a0 plus a1 x1 minus x0, y2 as a0 plus a1 x2 minus x0 plus a2 x2 minus x0 multiplied by x2 minus x1 and so on. Now since we have taken x as the equidistant data points, so the distance between two consecutive points will be h. Therefore, we can write x1 as x0 plus h. Similarly, x2 will be x1 plus h. Similarly, x3 will be x2 plus h. Moving forward in the same manner, we will get xi plus k is equal to xi plus k times h, or we may write it as xi plus k minus xi is equal to kh. Putting these values of x1, x2, x3 and so on in the previous equation where we have calculated y0, y1 and y2, we will get y0 as a0. Further, we will get y1 as a0 plus a1 into h. Moving forward in the similar way, we can calculate y2 up to yn plus 1. I have named these equations as 2, 3, 4 and 5 as you can see. Now we have to obtain the values of constants like a0, a1, a2 and so on. For finding the values of these constants, you can see that a0 is equal to y0. From here we can calculate the value of a1. Let me write it down for you. a0 will be y0, a1 will be y1 minus a0 divided by h. We may write this a0 as y0, and overall y1 minus y0 is the delta y0, which is the difference between the two consecutive terms. Next we have to find a2 using the equations second, third and fourth. We will get a2 as y2 minus a1 into 2h minus a0 by 2h square. Let's solve it further. Here I have replaced a1 by y1 minus y0 by h and a0 by y0. Therefore, we finally get a2 as delta square y0 divided by 2 factorial multiplied by h square. Similarly, we can calculate the value for an. Putting these values of constants a0, a1, a2 up to an in equation number 1, we will get yx as y0 plus delta y0 by h, x minus x0 plus delta square y0 by 2 factorial into h square, x minus x0, x minus x1 and so on. I have named this equation as equation number 6. Now let us recall that initially we have considered that u is equal to x minus a divided by h, where a is the base value or x0. So I can rewrite it as x minus x0 divided by h. So from x minus x0 by h is equal to u, you can get x minus x0 is equal to h times of u. Similarly, you can calculate for x minus x1 and x minus x2 and so on. Putting these values in equation number 6, that means we have to put the values here. We can rewrite our equation 6 as yx is equal to y naught plus delta y naught by h times u, plus delta square y naught by 2 factorial h square, h minus u, h into u minus 1, and so on. And this is finally known as the Newton forward interpolation formula. So this is known as the Newton forward interpolation formula. In the next videos, we will solve the examples related to this method. So stay tuned for the upcoming videos. If you have any doubt, then you may ask in the comment section below. Thanks for watching. Don't forget to like, subscribe and hit that bell icon for more such videos. Have a nice day.